Hello all, welcome back to the 5 Minute Tech channel. In this series we'll be talking about the different important design patterns. So first we will begin with decorator pattern. Decorator pattern The decorator pattern allows behavior to be added to an individual object, which could be a real life scenarios as well, dynamically without affecting the behavior of other objects from the same class or implementation. The decorator pattern is often useful for adhering to the single responsibility principle, and as it allows functionalities to be divided between classes with unique areas of concern. Decorator use can be more efficient than subclassing because an object's behavior can be augmented without defining an entirely new object. So enhancing a particular class by writing additional implementations rather than so for that case we can use a decorator pattern. So what are different participants? The participants are like component, example events. Then we have the concrete components, or example we have a movie or a conference. We have different decorators for these concrete components, and the concrete decorator is there, which is example it could be a bookable of bookable type. So we define the component as an interface for objects that can have responsibility added to them dynamically, whereas the concrete component defines an object which has additional responsibility to which additional responsibility can be attached. A decorator itself maintains a reference to the component object and defines an interface that conforms to the component's interface, and whereas the concrete decorator adds responsibilities to the component. So we'll be talking these in details in the demo, which I'll be showcasing next. So switching over to the Visual Studio, here I have a console application in C#. To begin with, we have a simple interface called iEvent. So we have an interface called iEvent, maps to the component part, wherein it has an interface and it has one implementation of booking a ticket. It is implemented by the class called event, which has different properties like name, duration in hours, price, etc. And it also implements the method called book ticket, and also it has an overload for us to see the representation when we run it. Following this, we have event decorator. The event decorator takes that interface iEvent, and it gets the details of the event and provides a virtual implementation of book tickets. Similarly, we have different types of events. So we have a conference event, which is like a conference decorator, we can say. The conference decorator takes the event decorator, which we just talked about, and it has an override on the book ticket method, and it goes ahead and add a lunch hour to the conference, and this is how it is added hours to the property. Similarly, we have a movie decorator which implements the event decorator, and it overrides the book ticket, and it adds the amount of hours interval minutes. So this is the representation, and after this we have a program file which is representing the actual implementation. So I'll go ahead and run this application. So if you see here, it first goes to the event, then it goes to our conference decorator, as you can see in here, and it then goes to the movie decorator. So all these decorators have additional implementation on top of the base implementation as per the requirement. So that will be all for this design pattern called decorator pattern. Hope you enjoyed the video. Have a nice one.